Okay, let's take a look at transformation of trig functions. And before we get too terribly carried away here, I think it's really important to start off by saying that when you do these transformations, you're really just drawing the same shapes over again, but you're either squashing them from left to right or squashing them from the top. Okay, so when we draw our sine graph, just kind of keep in mind that the pattern that we follow is from 0 up to max, back down to 0, down to min, and then back to 0 again. So when I go to change where these points are, so I kind of got 5 reference points there, kind of like a skeleton for the sine graph. Okay, all I'm going to do is I'm going to like squash this graph in this way and this way, but I've still got that same pattern of those 5 points. It's still going to go from 0 to a max or a min, down to 0 to a max or a min, back to 0. Okay. Likewise with cos, I'm going to start at a max, get down to 0, get down to a min, back to 0, and then back up to a max. And depending how the transformation is, it might start at a min down here, and then 0 and back up to a max, but you get the idea. Okay, so just remember that it's these kind of 5 points for each of these graphs that are going to remain as the skeleton, and then we're just going to change kind of the values around those skeleton points. Okay, so here's the setup. Okay, A is our vertical stretch. Okay, so that means that whatever we do to A is going to yank the graph in this direction or this direction, right? It's either going to squash it and shrink it vertically. And B is your horizontal strink or stretch. And here we want to divide those x values by B instead. Okay, so our absolute value of A is called the amplitude. Okay, so for wherever our middle point for our graph here is, okay, our amplitude is this value right here. Okay, make sure you don't get it confused with this value. Okay, the absolute value cuts from where our x-axis is up to the top of the graph, as long as we're starting at 0, 0. Okay, as long as there isn't some sort of translation to the graph, it's going to be cut in half at 0 there. Okay, so that's the amplitude. And the period of the function is normally 2 pi for sine and cos. So when we change B, okay, the period of our new graph is going to be that 2 pi, not times this time, but divided by B. Okay, so when we go to do some sort of a shrink or stretch in this direction, okay, we're going to label it like that. Okay, we're going to go 2 pi over B. Right, so let's keep cooking here. Okay, so let's do an example. All right, so it says g of x is 3 sine of 2x. So my period here is going to be 2 pi over my b, which is 2, which gives me a period of pi. And my amplitude is going to be the absolute value of plus 3, so that's just 3. So this is how that is going to play into our points. So regularly, my sine graph would look like this, right? Sine x would go 0, 0, okay, up to 1, down to 0, down to negative 1, and then back up to 0. Okay, so this would be a pretty good picture of one period of my sine graph, right? Okay, but so when we go and change one of the points, well, here let's put 0, 0 in again, because if I multiply or divide by my period or my amplitude there, nothing really changes. I still get 0, 0 there, right? Okay, but now my x values get changed by my b, okay, which was 2. Okay, b is 2, so all of these are going to get divided by 2. So instead of putting pi over 2 here, I'm going to put in pi over 4. Okay, so I divided by 2 there, and then my amplitude I'm going to multiply by 3. So divide for x's, multiply for y's. Okay, so it's, yeah. So let's go ahead and plot that point in here. So pi over 4 is in between pi over 6 and pi over 3. So it's going to be right there. So that's pi over 4, and we'll go up 3. Okay. And just like all of the distances for x here, like here I went every pi over 2 before I got to my next skeleton point, right? So pi over 2, another pi over 2 to this, another pi over 2 to here, another pi over 2 to here. Those distances were all pi over 2, right? Okay. So that means when I look at this, all of my distances for this graph are gonna for in between my skeleton points are gonna be a distance of pi over 4, or kind of like 1.5 pi over 6's, right? Okay, so here I've got pi over 4 and 3, so I know that I'm going to go 1/2 and another 2, and that's going to get me back to my next point. And let's see if that works. So I should, if I do this right, I should be at pi over 2. And sure enough, pi divided by 2 gives me pi over 2. And that's 0 there. Okay, so my next point, I would expect, so I went maximum, minimum, or 0, and now I'd expect to go another pi over 4 over, and hit a minimum. So I'm going to have minus 3 here, right? Okay, so that looks like we're going to get 3 pi over 4 and a minimum of minus 3. So everything's working slick here. Okay, and then finally, last but not least, let's do it on the graph first. So I'm going to end up hopefully at pi, and I want to come back up to 0. So I've gone 0 max, 0 min, sorry, 0 max, 0 min, back up to 0. So here at pi, which is where my graph looks like, I go 1.5 over, puts me at pi, and it puts me back at 0. Okay, so this is what we want to see for the graph of 3 sine 2x. And now every time we do this, so I go 1.5 over this way, okay, it's going to be down 3, 1.5 again, back to 0, 1.5, up to 3, 1.5, down to 0, 1.5, down to 3, negative 3, 1.5, 0, 1.5, goes up to plus 3, and then finally our last 1.5 goes here. So as long as you kind of understand that what the first interval is here, you can kind of follow the pattern of the graph, right? So every pi over 4, I need to put another point, and I just follow 0 min, 0 max. Okay, same here. So 0, I'm going to go max. So pi, go to this hash point, and then another pi over 4 this way, another pi over 4, and finally one last pi over 4. So at each one of these places, I'm going to go 0 max, 0 min. Whoops, I should have went down to here though. 0 min, and then back up to 0. That gets you a nice class. So what's the domain of our graph here? Well, I could keep doing that forever. It's all real numbers. And my range is going to go from, there's no graph down here, but as soon as I hit minus 3, there's graph, and up to 3. Okay, so let's whip through one more of these. Okay, so I'm going to leave number 2 for you guys, and then we'll go to kind of a trickier one, I guess, if you could call it tricky, in number 3. Okay, so here we got a couple of fractions, and they threw a fraction at us. So when I go to do this, I see it's a sine graph. So it starts at 0, 0, just like it normally would. And so for my x, well, this is just going to be 0, 0 again. But my first change up here, I'm going to have to divide by a half, which is the same as multiplying by 2. So this is really going to go to pi. Okay, and then my first trip up, I'm going to have to multiply this 1 by 4. So my period here is going to be the same as 2 pi over b, which is equal to 2 pi times 2 divided by a half, or times 2 gives me 4 pi. Okay, and my amplitude here is going to be 4. Okay, so I already know my range here. I know that my graph is going to kind of top out at plus 4 and bottom out at minus 4. Okay, so that shows my amplitude. And yeah, so let's go give this a try. And my little pieces over from going up and down are going to be pi units. So I'm going to start at 0. At pi, it's going to go up to 4. At 2 pi, it's going to go down to 0 again. Okay, and then let's do a little bit this way. So if I go to negative pi, that's going to be at negative 4. And at minus 2 pi, it's going to come back up to 0. So I'm still following the same pattern, right? So if I started here, okay, I'm going to go from my 0 to my max, back down to 0. And if I had more graph down here, I'd go down to min, back to 0, and then on and on. Okay, but because I don't have that, I'm going to go in the negative direction. So if I go back pi, it went max, 0, min, and then back up to 0 here. Whoops. Okay, and if we want to go fill the points in here, okay, so I guess I'm dividing by a half, so multiplying by 2 gives me 2 pi and 0. Multiply by 2 here, that gives me 3 pi and negative 4. And multiply by 2 gives me 8 pi, or sorry, 4 pi and 0. Okay, so those would be a few of the points that would be on there. Okay, so let's give number 4 a go here. So let's start with my period. So I'm going to go 2 pi times, or divided by pi over 4. So times the reciprocal gives me times 4 over pi. Okay, so the nice thing here is that my pi's cancel out, and my period is left as a whole number. So there's no pi. I'm not measuring in terms of pi anymore, but I'm measuring in terms of whole numbers. So my period is going to be 8 radians. Okay, so my amplitude looks like it's going to be 3. And just remember that the amplitude is always measured as positive. Even though it says minus 3 here, my graph is still going to top out at plus 3 and bottom out at minus 3. Okay, so let's go ahead, and at 0, I guess I'm going to be at, looks like minus 3, right? Okay, and now when I multiply 4 over pi by pi over 2, so I'm dividing pi over 2 by pi over 4, and so I multiply by the reciprocal, that's going to give me 2 and 0. So now every time that I go up 2, I'm going to hit, so I'm starting at a min, I get to 0. Every 2, I'm going to do that pattern. 0, max, min, 0, max, min, and on and on. Okay, so, or actually, yeah. Okay, so at 4 here, I'm going to get up to 3. At 6, back down to 0. And at 8, back down to minus 3. So that's the pattern that the graph is going to follow. Here's my skeleton points, and every 2 units it's going to hit plus or minus 3. So let's plop those down there. So I'm going to start here, 2 and 0, middle, up to max at 4, down to 0 here, and then at 8, which would be over here someplace, it's going to be down, it's going to be at a minimum again. Okay, on the other side, go over 2. I was at a minimum here, so back to 0, 4, up to max, and 6, back down to 0. And there is a nice little look-see at the graph of, whoops, ooh, a little crazy there, graph of minus 3 cos pi over 4 x. Okay, so give number 5 a try, and you should be ready for next time. Adios.